Hello students, now we will discuss about thermal power plant. Thermal power plant. Power plants convert solar radiation into heat. The resulting thermal energy is subsequently transferred into mechanical energy by a thermal engine and then converted into electricity. For the thermodynamic reasons, high temperatures are required to achieve the utmost efficiency. Such high temperature are reached by increasing the energy flux density of the solar radiation incident on a collector. According to the type of solar radiation concentration, solar thermal power plants are subdivided into concentrating, that is power and line focusing systems, and non-concentrating systems. The former classification can be further made according to type of receiver of the solar radiation, the heat transfer media and the heat storage system, additional firing based on fossil fuel energy. Concentrating system concept. The solar tower power plants, that is central receiver systems as point focusing power plants, dish Stirling systems as point focusing power plants, parabolic trough and Fresnel trough power plants as line focusing power plants. Concentrating collectors can reach temperature levels similar to that of existing fossil fuels fired the thermal power stations, example power plants fired with coal or natural gas. Non-concentrating systems concepts. Solar updraft tower power plants, solar pond power plants. This is the solar thermal power plant. The plants are electricity generator plants that utilize energy from the sun to heat a fluid to a high temperature. This fluid then transfers its heat to water, which then becomes superheated steam. This steam is then used to turn turbines in a power plant, and this mechanical energy is converted into electricity by a generator. This type of generation is essentially the same as electricity generation that uses fossil fuels. Facts about solar thermal energy. Solar thermal energy has been used in various ways, ranging from simple fire starting with a pocket mirror to solar architecture to capture heat in buildings. 48% of the sun's energy is in the infrared spectrum, invisible to the human eye as heat. Solar thermal collectors can employ nearly the entire solar spectrum. Process of solar thermal power generation. Concentrating solar radiation by means of a solar collector system, increasing radiation flux density, that is concentrating of the solar radiation onto a receiver. Absorption of the solar radiation, that is conversion of the radiation energy into thermal energy, that is heat inside the receiver. Transfer of thermal energy to an energy conversion unit. Conversion of thermal energy into mechanical energy using a thermal engine, example steam turbine. Conversion of mechanical energy into electrical energy using a generator. Solar tower power station. Main principles and components. Central receiver system in the tower. Mirrors tracking the course of the sun in two axes. Heliostats reflect the direct solar radiation onto a receiver centrally positioned on a tower. In the receiver, radiation energy is converted into heat and transferred to a heat transfer medium, example air, liquid, salt, water and steam. This is the solar tower power station. Heliostats. Heliostats are reflecting surfaces provided with a two-axis tracking system which ensures that the incident sunlight is reflected towards a certain target point throughout the day. Heliostats commonly concentrate sunlight by means of a curved surface or an appropriate orientation of partial areas so that radiation flux density is increased. Heliostats consist of the reflector surface, example mirrors, mirror facets, other sunlight reflecting surfaces, a sun tracking system provided with the drive motors. Foundations and control electronics. The individual heliostat's orientation is commonly calculated on the basis of current position of the sun, spatial position of the heliostats, the target point. The target value is communicated electronically to the respective drive motors via a communication line. This information is updated every few seconds. The concentrated surface size of currently available heliostats varies from between 20 and 150 meters square to date. The largest heliostat surface amounts to 200 meters square. This is the faceted glass metal heliostat. Second picture shows the metal membrane heliostat. Due to economic consideration, there is a tendency to manufacture heliostats with surface ranging from 100 meters square and 200 meters square and possibly beyond. Manufacture smaller heliostats reduce cost by efficient mass production. Controller. Heliostats are usually centrally controlled and centrally supplied with electrical energy. As an alternative, autonomous heliostats have been developed which are controlled locally. There, the energy required for the control processor and the drive is provided by photovoltaic cells mounted parallel to the reflector surface. Heliostat fields. The layout of a heliostat field is determined by technical and economic optimization. Heliostats located closest to the tower present the lowest shading. Heliostat placed north on the northern hemisphere or south on the southern hemisphere show the lowest cosine losses. Heliostat placed far off the tower, by contrast, require highly precise tracking and depending on the geographic locations have to be placed farther from the neighboring heliostats. The cost of the land, the tracking and the orientation precision thus determine the economic size of the field. Cosine losses representing the difference between the amount of energy falling on a surface pointing at the sun and the surface parallel to the surface of the earth. Receiver. Receiver of solar tower power stations serve to transform the radiation energy. Nowadays, common radiation flux densities varies between 600 and 1000 kilowatt per meter square. Receiver's classification according to the applied heat transfer medium and receiver geometry. The applied heat transfer medium example: air, molten salt, water, steam, liquid, metal. The receiver geometry example: even cavity, cylindrical or cone shaped receivers. According to heat transfer medium, water, steam receiver, salt receiver, open volumetric air receiver, closed pressurized air receivers are present. Water stream receiver. First, solar tower power stations. Similar to conventional steam processes, water is vaporized and partly superheated in a heat exchanger, that is tube receiver. Since superheating is prone to unfavorable heat transmission and due to the fact that startup operation or part load operation require complicated controls, this approach is currently not developed further. This is the water stream receiver. Salt receiver. The heat transfer medium applied for this secondary circuit should have a high heat capacity and good thermal conduction properties. Molten salt consisting of sodium or potassium nitrates compiles with these requirements. Disadvantage of all such salt receiver: the salt must be kept liquid also during idle times when there is no solar radiation. This requires to either heat the whole part of the installation that is filled with salt and thus increasing the energy consumption of the plant itself, or to completely flush the salt circuit. Thank you.